Physics, generator. So figure 8.1 shows the diagram of a simple AC generator. So remember, there are two types of a generator. There is an AC generator and there is a DC generator. So this is an AC generator. First question is, name the parts labeled X and Y. So now we have these are magnets. So this is the South Pole, this is the North Pole. So this is a magnet, this is a magnet. So that is it. These two, they are permanent magnets. And this is a coil. Okay? This is a coil. That is a coil. And then we have X. So this and this. So we call this as a slip ring. This is a slip ring and this is a slip ring. We have Y. So Y, it is a carbon brush. I can ask you to give the functions of the carbon brush. So the function of the carbon brush, it conducts current between the stationary part and the moving part of the coil. So this is the moving part and this is a stationary part. Okay, so this is the moving part and this is the stationary part. Okay, then we have slip ring. So the function of the slip ring, it is to ensure that there is a continuous electrical connection to the stationary brushes. Okay, or in other words, we can say that to make contacts with a conducting brush, and this maintains the closed circuit even as the coil rotates. Ring. So the function of the slip ring, its function we have Y, which is carbon brush. So that is carbon brush. So carbon brush, it conducts current between the stationary part and the moving part of the circuit. Part B, name 3 ways in which the generator would be made to produce more voltage. So the generator could be made to produce more voltage. Number 1, by using a coil with more turns. Number 2, by using a strong magnet. Number 3, by rotating the coil faster. Part C, explain how an AC generator operates. So how does an AC generator operate? So number 1, the coil, it rotates. So as the coil is rotating, it will cut the magnetic field lines, and that it will induce the electromotive force and current in the coil. These two are magnets. This is a coil. So the magnetic field lines will be moving from the north to the south, the magnetic field lines. So as the coil is rotating, it is cutting those magnetic field lines. So once the magnetic field lines, they are cut, the electromotive force and current is induced. In other words, it is produced in the coil. So that is point number one. Then point number two, the current that is generated has to flow forward for each upstroke. When this coil strokes upwards, current will go forward. Then when it strokes downwards, then current it will move backwards. That's why it is called the alternating current generator. To alternate, it is to change. Okay. Then number 3 point is that the coil, when the coil is in a vertical position, there is no current that is produced because it will not cut any magnetic field lines. Then when the coil is horizontal, it will cut the magnetic field lines. So that makes current to be what? To be induced at its maximum what? Maximum point. So multiple choice question. So the diagram shows a coil in a magnetic field which is part of an AC generator. So this is an AC generator. We have magnets, we have the coil. The question is, what must be connected directly to X and Y? So what must be connected directly to X and Y? They are slip rings. So there is a difference between split rings. Split rings, they are found in the DC generator, but slip rings, they are found on an AC generator. So this is our answer. So slip rings must be connected directly to X and Y.